Hello everybody. Welcome back to another interesting video on combinatorics. In this video, I'm going to talk about the pigeonhole principle. So what does this principle say? It says that if there are n plus 1 pigeons and n holes, there must be one hole with 2 pigeons. Before we look at an example about this, I must say that this is a simplified version of the principle. We will talk about the actual one in a second. Okay, so let's try to visualize this. Let's take an example where n is 2. So that means that there are 2 holes and n plus 1 is 3, so there are 3 pigeons. So if we try to put every pigeon into a hole, we can guarantee that one hole would definitely have 2 pigeons. It could be that all 3 pigeons are in one hole, but the point is that one hole would have at least 2 pigeons. Using this, let's try to answer a question. The question goes, prove that in a group of 13 people, at least 2 have their birthday in the same month. Now, the first step is to identify what the holes and what the pigeons are. Usually this is the hardest part in the question, but in this case, this is a really easy one. Here, the months are the holes and the people are the pigeons, and each person belongs to one month, just like how each pigeon belongs to one hole. We know that there are 12 months, so that means that there are 12 holes and 13 pigeons. Now the pigeonhole principle tells us that there must be at least one hole with 2 pigeons. We are actually finished with the question. Let's jump into the actual pigeonhole principle, which is more generalized. A more generalized version of the pigeonhole principle goes, if there are n holes and m plus 1 pigeons, there must be at least one hole with m plus 1 pigeons. That meant that if there are 2 holes and 5 pigeons, there must be one hole with 3 pigeons. Let's visualize this for a second. Like we said, n is equal to 2. That means that there are 2 holes. Let's distribute the 5 pigeons into the holes. After distributing it like this, we find that in the end, there will be one hole with 3 pigeons. One important thing that you need to understand is that they don't have to be distributed equally. All 5 pigeons can go to the same hole. That still proves this principle, because the principle says at least 3 pigeons. Now let's work with the numbers, so we don't have to draw pigeons in circles all the time. n is equal to 2, and mn plus 1 is equal to 5. If we replace n with 2 in mn plus 1, we will find that 2 times m is 4. That obviously means that m is 2 after dividing by 2 on both sides. That means that there will be at least m plus 1 pigeons in one hole, which is 3 because you have 2 plus 1. We have used the pigeonhole principle, or PHP for short, to prove that 3 pigeons go into at least one hole. Before we end off this video, let's go through one last question. There are 31 people from 6 countries. Prove that there were 6 people from one of the countries. The step 1 always remains the same. It is to identify what the holes and the pigeons are. This is also another easy example, so it's obvious that the countries are the holes and the people are the pigeons. That means that n is 6 and mn plus 1 is 31. Let's replace the n with 6 and shift the plus 1 to the other side. We get m times 6 is 31 minus 1. That is m times 6 is equal to 30. Dividing 6 from both sides, we get m is equal to 5. That means that m plus 1 is equal to 6. The PHP tells us that there is one hole with 6 pigeons, and we are done. I hope you have learned something from this video. If you have, consider liking and subscribing. See you in the next one.